day everyone, this is Engineer Royce Formaliza and welcome sa ating Principles of Communication. Okay, so ngayon, ang topic natin would be communication receivers. Last time, ang diniscuss natin about principles of communication is yung ating radio transmitters. Na-discuss din natin yung circuit ng isang radio transmitter and as well as yung iba't ibang blocks niya or iba't ibang parts niya. Tapos ano yung use ng bawat part niya. Okay, now as we know in electronic communication system, after our transmitter, diba? Nandun yung ating medium, ipapadala yan sa medium natin. That is, if this is wireless, so that would be our free space. And of course, it will be received by our receiver. Okay, so yan yung ating communication receiver. Now, na-discuss na natin yung transmitter. Today, we will be discussing about our communication receiver. Hindi natin i-discuss yung medium, yung free space, because there's a separate topic for this. Okay, so communication receivers lang muna tayo. Now, alam naman natin that in electronic communication systems, in radio communication systems, kaya natin siya ginagawa because of the main hindrance sa ating communication, which is distance. Diba? So, medyo malayo na yung kailangang i-travel ng ating information. So, what we do is yung information natin, pinapasakay natin siya into a higher frequency signal. Diba? So, ang analogy natin noon, if halimbawa, you are from a certain place and you would go into a far place, halimbawa, Philippines, pupunta ka ng let's say Japan, now you will not walk. Diba? So, ang gagawin natin is sasakay ka ng eroplano para makarating ka sa destination mo. That's the same thing with our information. Now, if the distance between the sender and the receiver is already significantly long, now we need a certain technique on how to transmit our information. Ginagawa natin is our modulation process. Pinapasakay natin yung ating information into a carrier signal, yung high frequency carrier signal natin. Diba? Tapos ipopropagate natin yan into free space and then it will be received by our receiver. Now, sabi natin, there is one aspect of all electronic communication system na hindi natin kayang matanggal. That is our noise. Diba? So, it is logical to say that after mag-travel ng information natin for a long distance, pagdating niyan dun sa ating receiver, yung transmitted signal natin will be very weak. It will be significantly weak compared to its level nung siya ay nasa transmitter side pa. So, nandyan syempre yung noise, nandyan yung attenuation, and then the signal will also experience absorption during its travel along the medium. So, pagdating sa receiver side, maliit na yung signal natin. Now, I have already said that one of the causes of this is noise, diba? So, kasama sa mga karakteristik ng ating radio receiver, dapat meron siyang or makakapag-provide siya ng magandang sensitivity and magandang selectivity to ensure na pagka dinimodulate natin yung ating receive signal, marirecreate natin yung information or yung intelligence signal. Marirecover natin na buo, na pure yung information na nanggaling sa transmitter. Now the question is, what is this sensitivity and what is this selectivity na pinag-uusapan natin? So sabi nga natin kanina, our receiver must be able to identify and select the desired signal. Now, sa receiver side, alam naman natin yung receiver natin. Ang sumasagap ng signal is yung antenna. Tama? Now, antenna lang yan, that is a pair of conductor. It doesn't have the ability to pinpoint alin dun sa mga signal yung desired signal natin. Kasi yung free space natin, if you can see the electromagnetic wave, diba? Kung meron kang capability to see the electromagnetic wave, makikita mo nandyan lahat yung mga signal. Nagkalat yan dyan. Now, halimbawa, ang desired signal natin is, let's say, for example, 100 MHz. Ang nakikita ng antenna dyan, marami yung 100 MHz. Okay? Now, ang isa sa ability or capability na kailangan natin for our receiver is to identify and select the desired signal. Bakit? Lahat kasi yan papasok dito sa antenna. Itong 100 MHz na to, ito, tsaka ito. Now, alin dito sa apat na to, alin dito yung desired or alin dito sa apat na to yung naglalaman ng ating information? Okay? Now, the ability of the receiver to identify and select that desired signal, that is what we call the selectivity. Identify and select. Kung ito pala yung ating desired signal, ito yung nagko-contain ng ating information. Tapos out of these 4, napili yan ng ating receiver natin. Na-identify niya na ito yung desired signal at ito yung pinili niya. Then we can say that our receiver has a high selectivity. Okay, so kailangan natin yan. We need a good selectivity. Pangalawa, the receiver must be able to provide sufficient amplification to recover our modulating signal. Bakit? Yung pinanggalingan ng mga 100 MHz na to, malayo yan. It traveled a long distance. So, kung nakikita natin yung power level nito, maliliit lang ang power level nito. Diba? It is not sufficient to drive yung mga circuit na nasa loob ng ating communication receiver. Okay? Now, sensitivity, this is the ability of our receiver to get the weak signal, to amplify it, and kapag dinimodulate niya yon, nakukuha niya pa rin yung modulating signal. Ganun siya ka-sensitive. Na kahit sobrang liit na nung power level, let's say power level nito mga nasa negative 107 dBm na. Diba? Ito, sabi natin negative 102 dBm. Okay, so sobrang liit na niyan. Pag ito, kaya niya pa rin itong ma-discern, diba? Using its internal circuitry, then we can also say that this certain receiver has a good sensitivity. Okay, so that is selectivity, sensitivity. Another definition, mas formal definition niya, a receiver daw with a good selectivity will isolate the desired signal. Okay? I-isolate niya yung desired signal And then, all the other signals with the same frequency, i-eliminate niya yun. Hindi niya papansinin yun. In other words, i-reject niya yun. Okay, kasi nakita niya na yung kanyang desired signal. That is selectivity. Sensitivity, a receiver with good sensitivity usually involves high circuit gain. Bakit? From this very low power level, we need to increase yung power level nito. Bakit? Baka ang nakikita na lang natin dyan is ganitong signal. Diba? Masyadong maliit siya na baka for us, we can consider this as, we can approximate this to flatline na lang, 0. Now, what we need to do is to amplify this signal. Diba? I-amplify natin siya. Pasok natin siya ng amplifier para itong signal na to lumaki. Diba? So, sensitivity is actually highly involved sa overall gain ng ating receiver. Okay, so yun yung titingnan nyo para hindi magulo yung term sa atin. When you say selectivity, diba, imagine mo, meron kang basket, madaming apples, ba, tapos halo-halo yun, may bulok, diba, tapos may nag-iisa doon na good apple pa. Your ability to pick, diba, i-isolate mo yung okay pa na apple and to reject all the other apples in that basket. That is selectivity. Okay? Now, sensitivity, ano naman yun? But tiningnan mo, no, yung basket. Pagkuha mo nung desired apple mo, kasi yun yung okay pa, tiningnan mo yung buong balat niya. Diba, tinitingnan mo talaga kung blemish free ba. Diba? Kasi baka naman yung isang part nun is may butas na, may uod na pala. So, that is sensitivity naman. Okay, nas kahit sobrang liit nung signal, kaya mo pa rin siyang i-reproduce. Okay? Now, let's dive into the selectivity and sensitivity. Na-define na natin siya, then, paano naman ito nag-work sa circuit? Selectivity in a receiver is, in technical, analogy. Selectivity, this is obtained by using tuned circuit. Na-discuss na natin yung tuned circuits and or yung mga filters natin sa mga previous discussion natin. Alam natin that a tuned circuit or a filter, nakatune nito sa isang frequency. Diba? Tapos itong tuned circuit na to, meron tong bandwidth. Bakit? Itong bandwidth na to, ito lang yung kanyang papapasukin. The rest, i-attenuate niya. Diba? That is our tuned circuit. As you can see here on the right, this is the graph of our tuned circuit. Itong blue trace na to. So, this is frequency versus the attenuation. Mapapansin nyo, itong FR, this is the resonant frequency. Dito nakatune yung ating tuned circuit. Ito yung pagka yung signal nung pumasok is equal to FR, meaning walang attenuation na introduce yung ating tuned circuit. Tapos ito yung negative 3 dB points, meaning pagka yung pumasok na signal is lower than F1, ito, and then higher than F2, lagpas na siya doon sa tinatawag nating bandwidth. Tama? I-attenuate niya yun ng sobra-sobra. Kaya mapapansin nyo, ito, pagkagaling niya sa negative 3 dB points, biglang nag-steep siya pababa. Tama? So, ibig sabihin, ang selectivity of this tuned circuit is ito lang. Itong bandwidth niya. Okay? So, bandwidth is actually a function of the figure of merit of our tuned circuit na Q. We can get bandwidth as the resonant frequency over the Q of the circuit. Q actually is the measure of the stiffness of our tuned circuit response. So kung mas kung mas stiff ito, mas mataas ang Q niyan. Mas mataas ang Q niyan, anong mangyayari? Mas maikli yung bandwidth. So pwedeng ganito siya ka-stiff. Kunyari lang yan hindi perfect na trace yan. Ayan. So ang taas ng Q nito, pero ang bandwidth nito, kung negative 3 dB, ang baba ng bandwidth niyan, ang liit. Okay? So that is our Q. Sabi nga by carefully controlling the Q of the resonant circuit, we can set the desired selectivity. Okay? So yun, i-adjustin natin yung Q. Then the selectivity of our tuned circuit, pwede natin i-vary. Gusto mo mas selective, taasan mo yung Q. Nga lang, masyado nang narrow yung bandwidth niya. Ibig sabihin, sobrang liit na nung makakapasok. Diba? The optimum bandwidth is wide enough to pass the signal and its sideband, but also narrow enough to eliminate or greatly attenuate signals on adjacent frequency. So, not necessarily na mataas yung kanyang selectivity is good na. So, hahanapin natin yung balance. Bakit? A certain signal, diba? Kung ito yung kanyang carrier, composite signal, diba? Either AM yan or FM, it will have its bandwidth. Diba? So, meron niyang, bandwidth, yung kanyang sidebands. So, meron niyang, kung AM, meron niyang upper side band and lower side band. Kung masyadong steep yung ating Q, so baka ma-clip off naman, di ba? Baka ganito siya, ma-clip off naman yung sideband natin. Di ba? So kung masyado namang wide yung Q natin, ba kunyari ganyan, baka naman sumama yung bandwidth nung or yung adjacent channels. Baka may sumamang part naman. So hanapin natin yung balance between the two. We want it to be as narrow as possible, or what I mean is we want it to be as selective as possible, but we also want it to be wide enough to accommodate the bandwidth or the sidebands of our desired signal. Okay, sabi nga dito, narrowing the bandwidth can only be taken so far. Okay, if we are going to narrow it as steep as possible, as narrow as possible, then we will come to a point where ma-attenuate na natin yung sidebands. Pati yung sidebands madadamay sa ma-filter out natin. Then it will result into a loss of information. Okay, so that is selectivity. The ideal selectivity curve is actually ito. Itong nasa taas. Vertical dapat siya. That is the ideal response of our filter. But we also know na hindi ganyan yung filter natin eh. Diba? That's not the practical response. Yung practical response niya is ito. Nasa baba. Now, itong sides na to, we call this skirts. The stiffness of this skirt, or yung tinatawag nating skirt selectivity, we express it in this term. Ang tawag natin is shape factor. Shape factor is actually the ratio of the negative 60 dB bandwidth. Nasaan yon? Kanina, tinitingnan natin ang bandwidth sa negative 3 dB point. Diba? That is the bandwidth. Now, what is the shape factor? Kukunin natin yan sa negative 60 dB tapos yung kanyang negative 6 dB. Paano yun? So, kukunin natin ito, negative 6 dB, itong points na to. And then the negative 60 dB, ito siya. So, if we are going to get the shape factor, ito yung formula niya. F4 minus F3. The difference of the negative 60 dB bandwidth. So, ito yon, F4 minus F3 over the difference of the negative 6 dB bandwidth. Ito po yun, F2 and F1. Ang makukuha natin dyan is our shape factor. The lower our shape factor, the steeper the skirts, and the better the selectivity. Okay, so ngayon, dalawa na yung ano natin, yung parang figure of merit natin. We can easily say if a certain receiver has a good or bad selectivity by just looking at the Q of the tuned circuit, and also by just looking at the shape factor. Tama? Q, the higher the Q, the better the selectivity. Shape factor naman, the lower the shape factor, the better the selectivity. Okay, so that is selectivity. Now let's move on to our sensitivity. Ano naman to? Sabi natin kanina, sensitivity, this is the ability of our receiver to pick up the weak signal, demodulate that weak signal. Of course, the receiver will amplify that weak signal, and then when it demodulates that weak signal, ang makukuha niya pa rin is an intelligible information. So that is the sensitivity. This is mainly a function of our overall gain. In general, the higher the gain of a receiver, of course, the better its sensitivity. Yan yung general idea. But there is another factor that affects the sensitivity of our receiver. We call it the signal to noise ratio. Okay? As you can remember, our amplifier will only amplify its input signal. So, yung amplifier doesn't have the ability to determine if yung input signal niya ay desired signal or noise. Ang gagawin lang ni amplifier, kung ano man yung in-input natin sa kanya, i-amplify niya lang. Diba? So, kung medyo mas malalim yung analogy natin, hindi laging tama na sabihin na the higher the gain, the better the sensitivity. Bakit? Baka naman kasi ang ina-amplify na lang natin is yung noise. Diba? Kaya nga sabi ko kanina, sensitivity is the ability to pick up the weak signal, amplify it, and when demodulated, it will still produce an intelligible signal. Kasi kung noise, kaya din yan. Diba? Mag-provide ako ng high gain, ipasok ko noise, i-amplify, tapos pagka na-demodulate, hindi yung desired signal yung nakuha, noise lang din. Diba? So that is not sensitivity. Sensitivity is pagka dinimodulate mo, yung information pa rin yung makukuha, and naiintindihan pa rin yung information. Now, a better measure of a sensitivity is our signal to noise ratio. Because alam natin na yung signal, when we propagate it in our medium, free space, this will experience noise, attenuation, and absorption. So, yung signal natin is bumababa. Diba? Nung desired signal natin. Lumiliit yung signal na pwedeng yung kanyang amplitude, yung kanyang power level is almost close to the noise level, or baka kapantay na mismo ng noise. If that is the case, may hirapan na tayong i-demodulate yung signal. Now, dito pumapasok yung signal to noise ratio. From the name itself, this is the ratio of the signal level to the noise level. What we want is to have a higher signal level and a lower noise level. So the higher the signal to noise ratio of a receiver, then the better the sensitivity of that certain receiver. Okay, so that is our sensitivity. As you can see here in this graph, this is actually a frequency spectrum. So, eto nakikita nyo, di ba ito yung desired signal natin? Sobrang taas niya. Tapos may mga bandwidth yan. Okay. Now, etong mga nasa baba na to, actually yung buong frequency spectrum mula sa extremely low frequency hanggang sa super high frequency up to X-ray, cosmic rays, this evenly distributed yun ng noise. May noise talaga yan, hindi natin yung matatanggal. Yun nga lang, sa sobrang liit ng noise, signal, we consider it as negligible. But if we are going to magnify that, makikita na natin na ito yung mga noise, itong nasa baba. May tinatawag tayong noise floor. For any noise that is lower than the noise floor, kinakancel na natin yon. We consider that as what they call this? We consider that as negligible. Okay, by doing that, so konting noise na lang yung mga titingnan natin. Ito na lang yung mga lumagpas sa noise floor. Diba? Now, if our desired signal is this one, itong mataas na to, so ang layo ng level niya, no? Ang layo ng kanyang they call this, ng kanyang signal level compared dito sa mga noise na to. Halimbawa, ito yung pinakamataas na noise. Ang layo ng signal level nila. Kung kukunin ko yung level niyan, ng signal to noise ratio niyan, aba, maganda yung signal to noise ratio nito. Mataas. Kasi masyadong malaki yung signal level compared to the noise level. Now, what if yung ating desired signal ay ito? Ito. So, masyadong maliit yung kanyang level compared dun sa noise. So, ano mangyari nito? Yung signal to noise ratio nito masyadong mababa. That is poor signal to noise ratio. Therefore, kahit anong gawin natin na amplify dito, sabay ding amplify si noise. Mas malaki yung noise compared sa kanya. Ano mangyayari? Ang mangyayari, parang ang dinidemodulate natin ngayon, yung noise, hindi yung signal. Okay? So that is sensitivity. One method of expressing the sensitivity of our receiver is to establish what we call the MDS, minimum discernible signal. So, ano ba yung pinakamaliit na signal na kaya pa rin i-demodulate ng ating receiver? So, we call that the MDS. Approximately, this is equal to the average internally generated noise value. Okay, so approximately. Kaya mapapansin nyo, itong MDS dito, almost pantay na siya sa noise floor natin. This is usually expressed in dBm. Another measure of receiver sensitivity, we can also use microvolts or decibels. So, pwede din i-express yung sensitivity ng ating receiver in terms of microvolts or dBm. Saan natin makikita yan? Hindi tayo yung define ng sensitivity ng receiver. Yung manufacturer or yung designer. Okay, so kung bibili ka ng radio receiver, then ito yung isa sa mga titingnan mo. Yung sensitivity ng radyo na yan. Okay, so syempre, there is selectivity, then sensitivity. So madami pa rin namang iba. Stability ng frequency niya, etc. etc. Okay, so naka-indicate to sa manual ng ating receiver.